Today we will solve a very new LeetCode problem, that is sum of square numbers. In this problem, we have been given a non-negative integer, that is c. Now you have to determine whether we can arrive at c by summation of a square and b square. So let's understand the problem by some test cases. In the first one, we have c equals to 5, and we can arrive at c equals to 5 by if we take a equals to 1 and b equals to 2. So 1 square plus 2 square equals to 4 plus 1, that is 5. So yes, c can be arrived, so we will return a true. Now can we, in the second test case, c is been given 3. Now can we arrive at c equals to 3? So if we take a equals to 0, b equals to 1, no, it's not possible for me to get c. Now if we take c, a equals to 1 and b equals to 0, still it's not possible. If I take a equals to 0, b equals to 2, no, it's not possible. We cannot arrive at c equals to 3 by any of the values of a and b. So we have to return as a false because we are unable to do so. So how to approach this problem? The first trivial approach that comes to our mind, let's take a two loop, that is A, it will run from 0 to C, right? And B, and another inner loop, that is B, which runs from 0 to C. Now I will determine if a square, if a square plus B square is C. Now if this condition holds, then just return a true, and if none of the combination is doesn't work, so just return a false. That's it. This is a simple approach, but it takes order of c square solution, order of c square, right? So it's a bit brute. So can we optimize this? Yes, you can optimize this by some constraint. So instead of looping, having two loops, let's keep a as it is. Earlier there were two loops. Now let's take as a loop. So a will run from 0 to c. Now for b, now we can do one thing for determining can we do one thing? Yes. Earlier the equation was a plus b square equals to c. Now I need to determine b, right? So what we will do? C minus a2, right? Now b2 is c minus a2. This is the b square. So the b square will, the value of b square will be, sorry, the value of b square will be c minus a2, right? Now, have you noticed one thing? This number b c minus a2 will be always a perfect square. Let's say for the first case, when c equals to 5, the a was 1, now b will be 5 minus 1, that is 4. Now 4 is a perfect square, right? It always be a perfect square b, because b square will be c minus a square. So b will always be a perfect square, right? So let's take another test case, that is a equals to, let's say if a is 2 and b is 3, it will yield something like 4 plus 9, it will be 13. Let's say c is 13, we have been given c equals to 13. Sorry, I didn't come up with any other test case. Let's say c is 13, so a will be 4. For example, a is 2, so a square will be 4. Now c minus a square will be of 9, right? 13 minus 4 equals to 9. So what will be the value of b square will be 9. Now the 9 is a perfect square number, right? C square equals to 9. So this value will always be a perfect square. So if I check it is perfect square of b2, if this condition returns true, then it is always true, right? If then I then if this function give me a true, because if the b square value, this value, if this one value is true, then it will always be of true. So we can arrive at this condition, arrive at the solution. So the time complexity of this approach would be order of c, because we are looping from 0 to c, into log of this number, this b2. This is this will be better than the c square approach. So let's code this up. So we have two numbers, a equals to We can take 0 as well because 0 is also possible. A plus plus. Now we have B. Now B will be C minus A square, right? B is C square. Now it will be perfect square, right? B should be for this number to be satisfied. Now this B must be a perfect square. So if this is perfect square, just return true. Yeah, this is the number. This is perfect. So let's write up the function of perfect square. Mhm. Now to calculate perfect square can be calculated in order of log in terms of logarithm complexity. So if L I take L as a one, because to describe these things how to calculate, let's say the num is 16, right? So 16 can be arrived at 4 cross 4, right? So what we'll do, I will loop from L equals to 1 to H equals to 16, right? Now my if my mid, let's say my mid is at 8, right? Mid is at 8. Now if I do 8 cross 8, then 8 cross 8, sorry. If I do 8 cross 8, then it is 56, right? Sorry, 64, right? Now 64 is greater than 16. So my result, my answer will always lie in the left subpart. So this is how the binary search approach comes to our mind. Now because 64 is greater than 16. Now if this is so, the mid 8 cannot satisfy my can never be my answer. So the answer must lie always lie in the left side part. So this is how we came to know it will require some binary search approach. So let's code this up. Let's calculate the mid. It is L plus H minus L by 2. Okay. Now let's say mid, if mid cross mid equals to num, then just return true because it is perfect square. Now if mid cross mid less than num, because mid cross mid, then the number will lies on the right subpart, is left subpart, left subpart. So if nothing matches, then return false. This is the normal, but this problem will give me a number integer in overflow, because if for big values of mid, these things will overflow. So what we will do, just divide it by mid, divide it by mid. It will also be divided by mid, so mid cross mid by mid. Now this number, generally in Java, the integer division returns a floor value. Like let's example, if my number is 17, if the mid is 4, now 17 cannot be a perfect square, right? Now if I divide 17 by 4, it will return 4. Now 4 equals to 4, this will return me true, but this is not right because the number 17 because the number 17 cannot be a perfect square. But it is a since the integer division returns a floor value, it will be return 4. So what to do? Let's add a guard clause, that is num mod mid equals to 0. This is very important. This is very crucial. You have to add these things up. Now let's run this thing. I think I am done. Yeah, I am done. Let's submit this up. We got a wrong answer. Why is so? Why is so? Because if C is 0, A to 0 is yes possible. C is 0. B will be 0. Now 0 cannot be a perfect square because L is rotating from 1. So I can take an edge case. I can handle this as edge case by C. If C equals to 0, just return true. Okay, I think we are good to go now, because zero cannot be perfect square according to according to my logic. Yeah, time limit exceeded. This was expected because my code isn't that much of optimized. Now let's understand this thing. Why it came? Because I am rotating from zero to C. Can we optimize this outer loop? The time limit clearly came because my outer loop runs from 0 to C. So there is a scope of optimization. So how to do this? Let's understand this. The range of A and B is from 0 to C, right? The range of A and B is lies from 0 to C. So I can do one thing. So A to B will be, since A to B lies from 0 to C, so A square and B square will always be from 0 to C, right? This is also true. So what we will do? B square, that also means B square less than equals to C. So what we will do? B will always be equal to square root of C. This is the one optimization we need to do. So if I do one thing, if I instead of iterating up to C, if I do square root of C, if I do square root of C, yeah, this is yeah, this it has passed. Currently we have passed. So the optimal time complexity, the final time complexity will be of order of, sorry, not do this here, just do this here. It it should be order of square root of C into log of, that is the number, that is B. We are calculating B. It is rotating from 0 to C, so it is square root of C into log of this number B. This is the optimal time complexity, and the space complexity is the order of 1. This is the number. This is the optimal time complexity, and this is the solution. Yeah, this is the optimal solution. It was a easy problem, but we needed to think a lot because we are asked to optimize a lot because the outer loop cannot run from 0 to C. Instead, it will do from 0 to square root of C because of this thing. It is a bit mathematical, so needed to understand this thing. And that's it from me. Thank you.